You know, when you look up at the night sky, you're not just seeing stars. You're literally looking back in time. And some of those glittering points of light, they're actually whole cities of stars. And every single one has a secret history. What we see is just a single snapshot in a story that's billions of years old. So today, we're going to hit the play button and uncover the hidden story of one of them. So this is our target. This beauty right here is Messier 52, a really brilliant star cluster tucked away in the constellation Cassiopeia. For the astronomers out there, you might know it as NGC 7654. And believe it or not, for decades, it's been holding on to a pretty big secret. All right, let's frame this up. I want you to think of this cluster as a kind of cosmic crime scene. It's just packed with stellar clues, right? You've got the brightness, the color, the position of thousands of stars. And for years, astronomers have been the detectives on the case, trying to piece together exactly what happened here, and, more importantly, when. And just to give you a sense of the scale we're dealing with, this crime scene is located about 1,380 parsecs away. Now, what does that mean? Well, that's roughly 4,500 light years from us here on Earth. So the light we're analyzing today actually left these stars back when woolly mammoths were still roaming our planet. Wild, right? Now, the very first challenge for any detective looking into this case is a big one. The evidence has been tampered with. Seriously, our primary clue, the starlight itself, is being changed on its incredibly long journey to get to us. So the culprit has a name. It's called interstellar reddening. Basically, there's this fine mist of cosmic dust just drifting between the stars, and it acts like a filter. It scatters the bluer light, which makes the stars behind it look redder and dimmer than they really are. But here's the catch. This cosmic smoke isn't a nice, even fog. Oh no, it's patchy. It's thicker in some spots, thinner in others. And this right here is the crucial point. The investigators in this study found that the dust is variable all across Messier 52. That means you can't just apply one simple correction. It means that looking at two stars that seem to be side by side might be like looking at one through crystal clear air and the other through a thick, soupy haze. So this variable dust created a huge puzzle that totally stumped astronomers for years. It turned this investigation into a cosmic cold case. No one could agree on a really fundamental fact. Just how old is Messier 52? I mean, just look at the conflicting reports here. You had some detectives saying it was 25 million years old. Others came back with 65 million. And one investigation concluded it was nearly 160 million years old. These numbers are all over the place. It was obvious that the early evidence was misleading, and someone needed to take a much, much deeper look. So how do astronomers even figure out a cluster's age? Well, this is their standard tool. It's called a color magnitude diagram. It's basically a chart that plots each star's brightness against its color. Now, young, hot stars and older, cooler stars, they fall into pretty predictable patterns. So if you just plot the raw data, ignoring all that messy, variable dust, you get what looks like a really clear pattern and a really clear answer. And that clear, simple answer points to an age of about 160 million years. So for a long time, this was the prime suspect for the cluster's true age. But, as we are about to see, this simple answer, it's a complete red herring. And here it is. This is the big aha moment. This chart shows what the star cluster actually looks like once the scientists carefully corrected each and every star for the specific amount of dust that was in its way. Once you digitally wipe away that cosmic haze, wow, the picture changes completely. And this new, clearer picture reveals the secret that Messier 52 was hiding all along. The stars in this cluster, they weren't all born at the same time. This wasn't one single explosive baby boom of stars. It was something much slower and much, much longer. So the cluster had what they call a protracted birth. What on earth does that mean? Well, it means the stellar nursery, the giant cloud of gas and dust that formed these stars, was open for business for a very, very long time. The data showed that the star formation actually happened in two different phases. First, there was this initial wave that produced the cluster's big, bright, really massive stars. Then, over a long, long period, a second, much slower wave came through and formed all the smaller, less massive stars that make up most of the cluster's population today. And the time gap between the oldest stars and the youngest ones? A staggering 70 million years. To put that in perspective, the star formation process in this single cluster took longer than the entire time that has passed since the dinosaurs went extinct. Just let that sink in. Okay, so this really drawn-out birth left a distinct legacy, kind of a physical imprint on the cluster that we can still see today. And it serves as another key piece of evidence that confirms this new timeline is the right one. This phenomenon is called mass segregation. Over millions and millions of years, gravity just does its thing. It's kind of like if you shake a can of mixed nuts. You know how the big Brazil nuts always seem to sink to the bottom? Well, in a star cluster, the most massive stars slowly sink towards the gravitational center. And guess what? That is exactly what we see in Messier 52. The heaviest, most massive stars are all concentrated right there in the core, while the lighter, smaller ones are scattered more broadly around the edges. This arrangement is the clear fingerprint of an older cluster, one that's had plenty of time to settle down, and it perfectly matches our new, much longer timeline. So the case is closed. The final verdict is in. Star formation isn't always a single flash in the cosmic pan. As the researchers themselves concluded, it can be a gradual, sequential process, slowly building a city of stars over tens of millions of years. You know, a discovery like this doesn't just rewrite the history of one star cluster. It really changes how we think about the birth of all stars and, by extension, the planets that orbit them. I mean, if a stellar nursery can be active for that long, a brand new solar system could be exposed to some wildly different conditions over millions of years. It leaves us with a pretty profound question to chew on. What does a 70 million year construction project mean for the odds of life ever finding a stable home?